2026 will likely be a big year for FDM 3D printing. At the end of 2025, Anycubic released its own high cost-effective, large format, multicolor printer, the S1 Max, and plans to start shipping in the next month. This video reviews the printer from a practical perspective, testing print performance with a variety of materials, comparing some printed parts with those from other machines on the market, and combining these results with a real usage experience from several practical projects. The main specifications of the S1 Max are build volume 350x350x350mm cube, Core XY, maximum nozzle temperature 350 degrees Celsius, active chamber heating up to 65 degrees Celsius, heated bed up to 120 degrees Celsius. When paired with Ace2 Pro, it supports up to 16 color printing. As for the standard features that ensure print quality, automatic bed leveling, active flow calibration, vibration compensation, and so on, they are all present, but I won't go into detail here. But how good is the actual print quality and the user experience of this machine? Next, I will walk through a series of real tests to find out. Also, thanks to Anycubic for providing the units that made this review possible. Several friends and I have been testing the S1 Max continuously for about 2.5 months, not only 1 month like most paid reviewers. If you are interested in this printer, you may have seen this Reddit post. And guess who's the OP? It's me. During beta testing, whenever we discover problems or bugs, we'll report them directly to a group chat and pressure the product managers and engineers to fix them. Also, this review only reflects the performance of my specific machine and the firmware version used during testing. Your own printer may perform differently. Feel free to disagree in the comments, it's not like I'm making any money from these videos anyways. PLA. Here are 4 benches printed in 15 to 18 minutes. Try to guess which one is from the S1 Max. I will give you 3 seconds. 3, 2, 1. Oops, none of them. The S1 Max one is here. Can you believe this quality from a 15-minute type speed benching? It can even compete with some machines printing at a normal speed, those 30 minutes benching. The steep overhang under the bow is quite clean. Even the large overhang under the bow came out fairly clean. Now look at the bridge in front of the bridge structure, very straight. Why is it so good? Because the S1 Max cooling system is insanely good. The 2 auxiliary fans draws air outside through the bottom vents and blow directly onto the model. In winter, the airflow in the middle of the bed still feels quite cold. I'm kind of worried the print might get freezed. Just kidding. If a 15-minute bench is already this good, then at normal speed, it's very solid. If you still don't have a clear idea about how good the cooling system is on the S1 Max, I will show you a more extreme bridging test. All fans were set to max, and prints were done on A1 Mini, P1S, S1, and S1 Max. Still hard to see? I will cut them open. A1 Mini, P1S, S1, S1 Max. At the top layers, S1 Max bridges are already well formed, while others are still loose. Can this be quantified? Yes. I will measure the thickness of the center of the bridge. While measuring, I applied a slight pressure on the caliper so the sagging lines do not affect the results too much. I will go over the result from the highest to the lowest. A1 Mini, 4.8mm, S1, 4.5mm, P1S, 4.4mm, and S1 Max, 3.7mm. Next is a CAD model to test Z-axis motion and extrusion stability under extreme conditions. The machine ran stably. The final result is average, nothing too outstanding. Bottom overhang roughness is expected since I printed without any support. Now multicolor printing. I used this Orca model when I was reviewing S1 and compared it to the Bamboo Lab P1S. Now I will print one again on the S1 Max for comparison. Overall, the result is good. But up close, there's a weird under extrusion on the rear right. On the bottom, there is a color bleeding under the head. Currently, purge volume before each print is insufficient, especially when switching from dark to light filament. Also, faint raining is visible in this white region on the head, though it's very hard to notice. Compared to other machines, P1S and S1 don't show any raining here, but S1 has odd layer lines. S1 Max has advantages too. The white region near the front fins is very clean, whereas the prints from P1S and S1 has some irregular layer lines. Moreover, the Orca from P1S has some dense vertical line on its dorsal fin, but S1 Max print turned out pretty smooth. This is actually my second print. The first print had 3 visible layer lines. I was about to blame Anycubic product managers and engineers until I rewatched the videos I took. These lines are caused when I opened the door and pressed my phone onto the bed to record because I wanted to take clear and stable videos. Lesson learned.
Do not push or pull the heated bed with your hand.
But this time, there is no weird under extrusion on the rear right, so I guess the defect I showed earlier is just an accident. I also printed a dual color bowl and a pair of chopsticks. Yep, vertically. I know this is the worst orientation possible, but it's fun to watch. Now I have a bowl and a pair of chopsticks, but I can't just leave the bowl empty. I printed 9 groups of small cylinders. None failed. Because I'm an early beta tester, I have 2 S1 Max combos now. With 2 H2 Pro units, I printed this ring in 8 colors. Check it out. Next is Silk PLA, which has somewhat mixed results. First is a low poly pen holder. Some areas show obvious staining, probably because the print speed happened to hit the resonance range. I would recommend increasing the outer wall speed and disabling overhand slowdown for better cooling for this kind of models when using Silk PLA. The top and interior surfaces looks excellent, and the bottom surface is also very smooth. But I'm sure most people use Silk PLA mainly for more decorative models like this one. Okay, PETG's turn. Let's start with a small model, a base for my turntable. Some small blobs appear in certain spots, probably due to suboptimal retraction settings. It's okay, I know how to calibrate the retraction of a filament. Oh well, this was a brand new official filament. Anycubic, seriously? Half of the filament bags arrive already losing vacuum. Can we just get better packaging? Also, the default PETG temperature is way too low, while only 230 degrees Celsius. As a result, the layer adhesion is poor. The printed benchy cracks easily when I pull it from the build plate. I also printed some very large parts using PETG. Because my room is small, I wanted to maximize the vertical storage space in my shelf for my models. Previously, I used cardboard boxes that eventually sag in the middle. Now I can replace them with plastic parts. Their base size is 295 x 315 mm squared, which many printers can't handle. To ensure strength, I increased the PETG temperature by 15 degrees Celsius. The final result, clean top surface and no missing extrusion. But there are some tiny dots on the side walls. Again, the default retraction setting in the slicer needs improvement. After tuning the print parameters a little bit, PETG prints came out much better. ABS. I printed quite a few ABS parts. They are mostly for fans, so I can't show them to you. Here are 2 cup coasters for my kitchen as examples. Since they are meant to hold hot cups, it makes sense to use ABS because they are more heat resistant. Here are the results: clean top surface, smooth sides, and no major defects. The default ABS profile on S1 Max is excellent, and the active heated chamber greatly reduces warping. PA nylon. Printing PLA, PETG, and ABS on S1 Max almost feels like wasting its capabilities, so I tried PA. At first, I wasn't sure what to print, but I recalled I printed some gears using nylons before due to its good impact resistance and self-lubrication. Why not print a few more for this review? Before printing, make sure your nylon is thoroughly dried. After drying and reprinting, the result looks great. PC, since polycarbonate is flame resistant, I printed a power strip holder. It clips onto the shelf bar and I can secure my power strips with zip ties. This is much safer and more stable than my previous setup. The print looks excellent. Interestingly, the surface quality came out almost identical to my earlier PLA prints when I was doing prototyping. However, large PC prints will still work, even with a 65 degrees Celsius chamber temperature. Warping can lead to layer shifts, which can affect the precision parts, but for my use cases, this isn't a big deal. The showcase part of this video ends here. I didn't test TPU since I almost never use it in daily printing, Honestly, I recommend KX for TPU prints. Let me show you the real-time monitoring feature on that. And here is a time-lapse video. Pro and cons, let's start with the pros. First, cooling is unbeatable. Here's my bold take. The S1 Max might have the strongest cooling among enclosed consumer printers right now. At the moment, it seems only the Bamboo P2S has a fan that draws air from outside, while most other machines pull air inside the chamber. The S1 Max is equipped with 2 auxiliary fans, double the cooling, double the fan. Second, extremely compact design. Compared to Creality K2 Plus, the S1 Max is smaller in overall dimensions. It's even more compact than Bamboo H2S. Why? Just look at the spacing between the heated bed and the other components. At the back, there isn't enough space to fit a flash drive. Looking from the front door, on the right side of the bed, you can barely fit one finger. On the left side, not even a finger fits. When the print head moves to the cutter, the nozzle almost touches the Z-axis rod mount. There are even cutouts on the bottom specifically to accommodate the bed connectors. This is pushing limits. Previously, Anycubic machine didn't have great space utilization. This time, they've redeemed themselves. Third, quiet printing. With active noise reduction this time, it's much quieter. Let's listen to the sound profile. S2 Pro versus AMS2 Pro during filament loading and unloading. Fourth, convenient quick swap hot end. Although reinstalling requires some repeated adjustment of position and angle, the overall modularity greatly improves maintenance efficiency. Fifth, significant upgrade to S2 Pro. This time it includes sealing strips. To preserve the original design, the sealing likely costs more than AMS since it uses 4 separate rubber strips. The new S2 Pro supports drying up to 65 degrees Celsius, which is 10 degrees higher than the first generation, more than enough for drying PTG. It also includes a door to exhaust moisture during drying and isolate external humidity when not drying. Each spool slot is driven by a brushless motor, enabling faster loading and unloading. The second gen filament pad is smoother and more wear resistant. The first gen required perfectly straight filament insertion, otherwise it would feed out in strange ways. That issue is now fixed. Sixth, purge outlet on the left side. This is convenient for most users. 7. Improved structural strength as rod spacing is wider than on the S1. Rod and belts are thicker, and the belt has been upgraded to 1.5 GT. 8. Glass panels. The front door and top covers are upgraded from polycarbonate on S1 to glass, significantly improving the overall look. 9. Stable first layer. Compared to the S1, the S1 Max's first layer is nearly perfect most of the time. Occasionally, it may still be slightly too high, but it doesn't affect the overall success rate. Now the cons. First, inaccurate print time estimation. Multicolor prints are usually longer than estimated. In some cases, even single color prints took twice as long as predicted. I suspect this is a firmware issue. Second, filament presets need optimization, especially for PTG. Third, cloud service instability. Anycubic's cloud service can go down for a day every 1 or 2 months. The machine doesn't come with a flash drive, so I recommend everyone to prepare one just in case. Fourth, filament unloading issues. Using the built-in unload function can lead to problems like this. This might cause tangles in the next print. Fifth, S2 Pro speed reduction. Over the past 2 months, it has gone through several speed reductions. Loading and unloading is now much slower. Supposedly for better stability, it would be nice to keep it faster. Sixth, not friendly to cardboard spools, especially with large diameter ones. Sometimes it gets quite scary. 7. Nozzle clogging when switching materials with large temperature differences. This usually happens when switching from PLA or PTG to PA or PC and vice versa. During preprint purging, lower temperature materials can soften above the heat break and cause clogs, preventing even the first layer from printing. The official response is that this will be fixed in a future firmware update. However, I still recommend that if you frequently switch materials, you should get an extra nozzle, one dedicated for PLA, PTG, TPU, and ABS or ASA, and another dedicated for PA and PC. Anycubic often feels like it's just one step short, but when they really put in the effort, they can absolutely get things right. Take this foreign cube for example. The one printed 2 months ago looked like this, but with the latest machine and firmware, the reprint is already close to perfect. So keep it up. After 2 months of real use, how good is the S1 Max? In short, it has clear strength, some rough edges, but its overall competitiveness is strong. Large build volume, sturdy quartz wireframe, dual cooling fan make PLA fly. 15-minute benchy prints clean and bright. Bridging performance shines out right. ABS prints steadily in heated space, nylon and PC, and can erase. PTG default feels a little odd, tuning them well and thank the gods. Structure tight, space push to max. H2 Pro improves the stack. Sure, it has flaws, software too. Cloud service sometimes goes askew. But overall, the target is clear. Large size, multicolor, without fear. For the price, the S1 Max still smells like a bargain. If firmware keeps improving and the software ecosystem catches up, the 2026 FDM battle might not be so easy for its competitors. At the very least, it might pressure them to lower their prices. If you want to buy this machine, you can use I'm not gonna put my affiliate link. I can earn some money through it, but it will likely make my review more biased, so I'm not going to do it.